Morning. Today we will be discussing the concept called search. So before I get into that, let me fix some terminologies and then we move on to that concept. Okay, so that is what we are going to do. So let me take this equation. X square is equal to 4. So x square is equal to 4. Here you can say that 4 is called the square of x and x is called the square root of 4. I repeat it again. 4 is called the square of x and x is called the square root of 4, and that x we can write it as square root 4. Whatever we are reading, we are trying to write in a symbolic form. That is what I have done. 4 is called the square of x and x is called the square root of 4. X is called the square root of 4. That statement I have mathematically written in the form of an equation. X is called square root of 4. So that is what. Let me also take some more equations. X cube is equal to 125. Now here 25 is called the cube of x and x is called the cube root of 25. And we write that symbolically as x is equal to cube root 125. On the similar lines, just like the way we are going with square cube, if I take the equation x power 4 is equal to 81, now I can say that 81 is the fourth power of x. I repeat it again. 81 is the fourth power of x, or x is the fourth root of 81. And we can write that symbolically as x is equal to fourth root 81. Similarly, suppose you have x power 5 is equal to 32. Now this is read as 32 is the fifth power of x. Equivalently, x is the fifth root of 35, and that you can write it symbolically as x is equal to fifth root, in fact 32. X is equal to fifth root 32. Suppose say if it is 6. So x power 6 is equal to some number, say some 256. X power 6 is equal to 256. Then we say that 256 is the sixth power of x and x is called the sixth root of 256. That is the way we will speak. Instead of going with 2, 3, 4, 5 and likewise, I will be generalizing this. Instead of saying 2, 3, 4, 5, 6, suppose if it is x power n is equal to y, then I will say that y is the nth power of x, and equivalently we can say that x is the nth root of y. I repeat it again. Y is the nth power of x and x is the nth root of y, and this is written as x is equal to nth root y. So this is what is it. This is what I am trying to fix now. Nth root y. What is nth root y? So this is what we call it as nth root y. Given x power n is equal to y, then we say that x is called the nth root y. Now that is what I will formally define. Now when you are looking into n, this n is a positive integer, the natural numbers 1, 2, 3, so on. Now if you are looking into that, n is not 1. We have started with 2. If n is equal to 1, there is nothing to speak about. For example, x power 1 is equal to 2, there is nothing to speak about. X is 2 itself. So there is nothing to speak about. So n starts from 2, 2, 3, so on and so forth. So n is basically a natural number greater than 1. So that is what we write. Let n be a positive integer greater than 1, and this x be any positive real number. Let us define it for positive numbers. So let n be a positive integer greater than 1 and x be a positive real number and x be a positive real number, and x is a positive real number in such a way that x power n is equal to y. X is a positive real number such that x power n is equal to y. Now we have to say what is y, where y is a positive real number, where y is a positive real number, then x is called the nth root of y. Then x is called the nth root of y, and it is denoted as nth root y. So this is what I am trying to fix. What is the nth root of a given number? So if n is a positive integer and x is a positive real number in such a way that x power n is equal to y, then x is called the nth root of y. Whatever we have discussed, I have restated in the form of a statement. That's it. Other than that, I have not done anything. So this is all about what is nth root of a given number. Now I'll be developing further more on this in order to arrive at the given concept of the day. So again, I am getting back to those equations which I have written. So x square is equal to 4, we have x is equal to root 4, then x cube is equal to 125, we have x is equal to cube root 125, then x power 4 is equal to 81, x is equal to 4th root 81. Okay. Now we try to find the value of x. In the previous case, we did not find the value of x, rather we are trying to see the terminology. If this is written like this, what x is called, what 4 is called here, what x is called, what 125 is called, that is what we have done in the previous case. Now we try to find the values of it. Now what is square root of 4? Square root of 4, you know it is 2. Why it is 2? Because 2 square is 4, that is this 4 can be written as 2 square, therefore the square root of 4 is 2. Like the same 125, can you write it as the cube of any number? Let us check out with 5, because you have 5 5s are 25, 25 5s are 125. So you are able to write 125 as cube of 5, therefore the cube root of 125 is 5. Now 81, can you write it as 4th power of any number? Let us check out with 3 3s are 9, 9 3s are 27, 27 3s are 81. So the square root of, the 4th power of, in fact 4th root of 81 is equal to 3. Like the same for suppose say 5th root of 32. 5th root of 32, can 32 be written as any number to the power of 5? Yes, check out with 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So you are able to write 32 as the 5th power of 2, therefore 5th root of 32 is 5. Now, since this number can be written as 2, since this number can be written as 2 power 5, I can say that 5th root of 32 is 2. Also here 81 can be written as 3 power 4, therefore we say that 4th root of 81 is 3. Like the same 125 can be written as 5 cube, so we say that cube root of 125 is 5. Now in these cases we are able to find a number in such a way that the 5th power of 2 is 32, 4th power of 3 is 81, cube of 5 is 125, square of 2 is 4. We are able to find numbers. Let us consider this. If suppose square root 17. Now square root 17. Can you find a number where the square of the number gives you 17? Yes. Is there any number whose square gives you 17? 4 square is 16, but it is not 17. Is there any number? Or say some 21? Is there any number whose square gives you 21? Or say cube root of 21, is there any number whose cube gives you 21? Yes, there are no numbers whose cube gives you 21, whose square gives you 17. Therefore, you cannot extract the square root over here and you cannot extract the cube root here. Here if you have considered, we can extract the square roots, cube roots, fourth roots, fifth roots likewise, because there are numbers where you can express that. Like 4 you can write it as 2 square, 125 you can write it as 5 cube. You are able to find such numbers. Whereas here in these cases, we are not able to find such number where the square of that number gives you 17. Like the same, square of that number, cube of that number gives you 21. Or of that matter, say some 35. There is no number whose fourth power is 35. Therefore, you cannot extract the fourth root of 35. Now, these kind of numbers, we call them as surds. That is, the numbers whose roots cannot be extracted, we call such kind of numbers as surds. And if you have seen, this number is not a rational number because it is not written in the form of, it cannot be written in the form of p by q, where p and q are integers, because these are not integers. Now if you look into this, root 4, it is 2, 2 is 2 by 1, therefore this is a rational number. So we can say that surds are all irrational numbers. That is what we can conclude. Surds are all irrational numbers. Now surd is any number whose root cannot be extracted, whatever it might be the root, whose root cannot be extracted, we call it as a surd. However, that is an informal form of defining a surd. Now let us define it formally. Okay, so let me define these surds formally. Now informally what we have defined is, if given a number, if you are not able to extract the root of that number, we are calling them as surds. Now how to define it formally? Okay, look into that. Right, so as we have started with x square is equal to 4, then this can be written as x is equal to square root 4. We have started with 2. And if it is suppose x cube is equal to some 7, we will be writing it as x is equal to cube root 7. That is, if this is cube, then here you have a cube root 2. If there is no 2, it is understood that we have 2. If there is no 2, it is understood that we have 2. Which means that here we have 2. If it is not written, so it is understood that is 2. For other numbers, we will be writing that. Now, if you have observed, all these numbers are positive numbers greater than 1. That is 2, 3, 4, 5, 6, 7, so on. All these numbers are positive numbers, but we are not starting with 1. So that is what I will write. Let n greater than 1 be a positive integer. So first I am discussing about these numbers. So n here is a positive integer. Now look into these numbers. Now if you observe these numbers, all these numbers are rational numbers and also they are positive rational numbers. So for all these numbers I am naming it as a. For all these numbers already I have named it as n. So let n be a positive integer and a be a positive rational number. Let n greater than 1 be a positive integer and a be a positive rational number. Now, if n is greater than 1 and a is a positive rational number, now if you write that in this form, all of them need not be a surd, because there might be some numbers. For example, cube root of 81. Cube root of 81 can be extracted, which is, or in fact, fourth root of 81 can be extracted, which is 3. It can be extracted because 81 you can write it as 3 power 4. But here, these numbers cannot be written as any number to the power of that particular n. Only such kind of numbers we are calling them as surds. See here 81 you are able to write it as 3 power 4. Here it is 4, you are able to write it as 3 power 4. Then that is not we are calling it as surd. We are calling such numbers as surds where this number, in fact these a's are not written as power of any number. That is, here in this case 35 cannot be written as any number to the power of 4. Here 21 cannot be written as any number to the power of 3. 17 cannot be written as any number power of 2. So if you are able to have such kind of numbers, then only we are calling it as surds. So that is what I will mention. That is n be a positive integer and a be a positive rational number. That positive rational number should be in such a way that a cannot be written as the nth power of any rational number. Then, so what I have mentioned here is this number cannot be written as square of any number. This number cannot be written as cube of any number. This number cannot be written as fourth power of any number. That is what I have mentioned. I have taken like this. N is a number which is greater than 1. We start with 2. Okay. And a is any positive rational number. If a cannot be written as nth power of any number, then we call it as a surd. That is what I am writing. So a is a positive rational number such that a cannot be written as nth power of any rational number. Then nth root a is called nth root a is called a surd of order n. If you are able to write it, that is not a surd. See, here fourth root of 81 you can write it as 3 power 4. Therefore, this is not a surd. Next, say fifth power of 25. Fifth power of 25 cannot be written as any number to the power of 5. Therefore, this is a surd. Like the same, fourth power of 16. Fourth power of 16 is not a surd because 16 can be written as 2 power 4. So these are the examples of surds. And also we have some more terminology. Let me fix that as well. Now here this a which you are taking is called a radicand. Here a is called a radicand. Then nth root is called a radical sign. Is called radical sign, and n is called the order of the surd. N is called the order of the surd. So let me fix this one. See, suppose cube root of 5. Now clearly that is a surd because 5 cannot be written as nth power of any number, or in fact cube of any number. Now here 3 is called your order, 5 is called your radicand, and cube root is called your radical sign. Cube root is called your radical sign. Let's say likewise, you suppose say square root 7. If there is no number, it is understood that there is 2. Therefore, the order of the surd is 2. Radicand is 7. This is your radical sign. Now, surd is also called radical. Surd is also called as radical. So surd is also called as radical. Now this is about the definition of a surd. That is, let n be a positive integer and a be a positive rational number such that a cannot be written as the nth power of any rational number. Then nth root a is called a surd of order n. Here a is called a radicand, nth root is called a radical sign, and n is called the order of the surd. And we have seen some examples, and surd is also called radical. And we have some forms here. Let me also look into such forms. So suppose say fifth root 7. Fifth root 7 is clearly a surd because 7 cannot be written as any number to the power of 5. Now here 5 is the order of the surd, 7 is your radicand, and fifth root is your radical sign. So this is what we have discussed. Now this form of writing is called radical form. Now this radical form can also be written in terms of exponential form. That is, fifth root 7 in exponential form you can write it as 7 power 1 by 5. That is, whatever the number you have, take that to the denominator in the exponent. That is, say if it is nth power a, then this is your radical form, then the corresponding exponential form is a power 1 by n. For suppose square root of some 19. So this is same as 19 power 1 by 2. There is no number, 2 is understood here. So that is the case. Now this is called your exponential form. This is called your radical form. So this is all about what is a surd, what are the different terminologies you have on surds, and what is the radical form, and what is an exponential form. So these are all about it. Now I have framed a worksheet basing on the same. The worksheet will be within the framework of all the definitions which we have discussed today. Go through it. If you are able to do the worksheet, then you will have a firm grip on this concept. So that is it all for the day. Thank you.